Now, let's check the key ideas with some IB-style practice questions. For practice 1, we are given an atom with 17 protons, 18 neutrons, and 17 electrons. The question asks which statement is correct. The most important thing to remember is that the atomic number is always equal to the number of protons. Since this atom has 17 protons, its atomic number is 17. So the correct answer is C. It is not negatively charged because the number of protons and electrons is the same. There are 17 positive charges and 17 negative charges, so the atom is neutral. Also, the mass number is not 17. The mass number is protons plus neutrons, so 17 plus 18 gives 35. So for this question, the correct answer is C. The atom has an atomic number of 17. Now let's move to practice 2. This question gives us a magnesium atom with 12 protons, 12 electrons, and 13 neutrons. We need to choose the correct nuclide symbol. In the nuclide symbol, the bottom number is the atomic number. That means it must be the number of protons. Magnesium has 12 protons, so the bottom number must be 12. The top number is the mass number. Mass number means protons plus neutrons. So we calculate 12 plus 13, which gives 25. That means the correct nuclide symbol is magnesium with 25 at the top and 12 at the bottom. So the correct answer is A. The key idea is simple. Bottom number means protons. Top number means protons plus neutrons. Now let's look at practice 3. This question asks which pair represents isotopes of the same element. Isotopes are atoms of the same element with different numbers of neutrons. Same element means they must have the same number of protons. So we are looking for two atoms with the same chemical symbol but different mass numbers. Option B shows chlorine 35 and chlorine 37. Both are chlorine atoms, so they have the same number of protons. But their mass numbers are different, which means they have different numbers of neutrons. That makes them isotopes. So the correct answer is B. The other choices are not isotopes of the same element because they use different chemical symbols. For example, carbon and nitrogen are different elements. Sodium and magnesium are also different elements. Oxygen and fluorine are different elements too. So remember, isotopes must be the same element. Now let's move to practice 4. This question is about relative atomic mass. Element X has two isotopes. X10 has an abundance of 20%. X11 has an abundance of 80%. We need to calculate the weighted average mass. This is important because relative atomic mass is not just a simple average. The isotope that is more abundant has a bigger effect on the final answer. So we multiply each isotope mass by its abundance. For X10, we do 10 times 20. For X11, we do 11 times 80. Then we add them together and divide by 100. So the calculation is 10 times 20 plus 11 times 80 divided by 100. That gives 10.8. So the correct answer is C. This answer makes sense because 80% of the atoms are X11. So the average should be closer to 11 than to 10. Now let's look at practice 5. This question is about flame tests, but we are not just asking which ion gives which color. The important question is why different metal ions produce different flame colors. When a metal compound is placed in a flame, the electrons in the metal ions absorb energy from the heat. Because they absorb energy, the electrons move up to higher energy levels. But these excited electrons are not stable there. After a very short time, they fall back down to lower energy levels. When they fall back down, they release energy as light. The color of that light depends on the amount of energy released. Different metal ions have different energy level gaps, so they release different wavelengths of light. That is why lithium, sodium, potassium, barium, and copper can produce different flame colors. So the correct answer is C. Electrons in metal ions absorb energy in the flame, and when they return to lower energy levels, they emit light of specific wavelengths. This is the key idea behind flame tests. The flame color is not mainly because different metals burn at different temperatures. It is also not because the metal ion simply absorbs a color of light. And it is not just because the metal reacts with oxygen. The flame color comes from electron transitions between energy levels. So remember the sequence. First, electrons absorb energy. Second, electrons move to higher energy levels. Third, electrons return to lower energy levels. And finally, light is emitted. That emitted light gives the characteristic flame color. Finally, let's look at practice 6. This question is about a mass spectrum of chlorine. The spectrum shows two main peaks at meters over Z35 and meters over Z37. The peaks are in about a 3:1 ratio. A mass spectrum can show the isotopes of an element. Each peak represents particles with a different mass to charge ratio. For chlorine, the two main isotopes are chlorine 35 and chlorine 37. The peak at 35 is taller, which means chlorine 35 is more abundant. The peak at 37 is smaller, which means chlorine 37 is less abundant. Because the ratio is about 3:1, chlorine 35 is about 3 times more common than chlorine 37. So the correct answer is A. Chlorine has two isotopes, and chlorine 35 is more abundant. It does not mean chlorine has two different charges. It does not mean chlorine atoms have 35 or 37 protons. Chlorine always has 17 protons. And it does not mean chlorine is a mixture of two different elements. It means chlorine is one element with two naturally occurring isotopes. So, to summarize these practice questions, there are a few key ideas to remember. Atomic number means the number of protons. Mass number means protons plus neutrons. Isotopes are atoms of the same element with different numbers of neutrons. Relative atomic mass is a weighted average based on isotope abundance. Flame tests can help identify metal ions, and mass spectra can show the masses and relative abundances of isotopes. If you understand these ideas, S1.2 becomes much easier.